Welcome to heat X. X stands most likely for exchange, and this is the so-called two-sided heater because it will require two streams or two main streams in the inlet. The cold fluid and the hot fluid going in and out. So remember that they will be here exchanging heat. Typically you have various options, the shortcut one and the rigorous one. But please note that you must have the Aspen Exchanger design and rating license and program in order to be able to calculate this. The shortcut will be a very raw heat X calculations, and what they do is essentially how the main overall heat transfer coefficient is calculated. And of course this will use geometry and this one does not. Now for the heat X, you must specify which one is the hot and cold streams. And if you mix them, then you will have some errors. So be sure to select them correctly. The outlet temperature, these are the following, let's say, operations. You have the outlet temperature, or you want to have the temperature change between hot and cold streams. Molar vapor fraction of either hot or cold streams. So let's say this is liquid and you want to evaporate it completely, then you select one. You can use the heat exchanger heat duty. You know that you need to use certain heat exchange values, so you do it here. Also, you can select the degrees of superheating, because when you select B1.0, this will be saturated. But if you wanted maybe, I don't know, you wanted 10 Celsius above its saturation point, you can do it. Also, you can add the surface heat transfer area. This will, remember, change these guys right here. So if U is relatively fixed and you increase the area, therefore you will increase the heat duty if the logarithmic temperature remains the same. Now the UA, which is the overall heat coefficient, overall heat transfer coefficient, might be added but is optional, so you don't need to. And okay, now once you open the heat X specifications, you are in the main flow sheet, add the heat X, add all streams, then double click on heat X. You will get this form right here. This is the model you want to add. This is either shortcut or detail, which is currently not available, and all these guys are rigorous. So let's analyze first the shortcut value. I typically recommend you guys start with the shortcut value, and if you have some problems with convergence, then fix them, because if you go directly to the rigorous values, it will be a little bit harder to get the error on convergence. Now for the shortcut value, you got the mass energy balance value. That will be, they are based on mass and energy balances. You require at least one specification, which is right here. You gotta state at least one. And if you have, you can select either constant heat capacity coefficient, or you can select the area. Whatever you choose, you must give it here. Also, the drop in pressure is optional. Now we're going to review these, of course, with some workshops. No, don't worry. Now it's time to study the heat exchanger with rigorous models.